Section 5.4, Factoring Quadratic Expressions. Factoring is rewriting an expression as the product of its factors. If I just gave you a real number such as 48, I can write factors of 48. In other words, what two numbers multiply together that equal 48? I could write 8 times 6. This is written as a product of its factors. In this case, there are multiple ways to write 48 as a product of its factors. I've written 8 times 6. I also could do 4 times 12. But this is an example of writing something as a product of its factors. What we want to do is actually do this in terms of an algebraic expression. With an algebraic expression, we want to use the greatest common factor, the GCF. That is the common factor of each term of the expression that has the greatest coefficient and the greatest exponent. In other words, I want to find the largest number that will divide into each coefficient of my expression, and I want to find the largest variable exponent that will divide into each variable term. Let's take a look at an example. Here, I have my expression 3x squared plus 12x minus 12. The first thing I want to do is find the greatest common factor for the coefficient of each term. Remember, the coefficient is the number that multiplies the variable, or in this case, I have a constant. So in the first term, I have 3 as my coefficient, 12 in the second term, 12 in the third term. The largest factor, the GCF, for 3, 12, and 12 is 3. Now what I do is I take each term and divide it by that factor. 3 divided by 3 is 1x squared, or just x squared. 12 divided by 3 is a positive divided by a positive, which is 4x. And a negative divided by a positive is a negative. 12 divided by 3 is 4. The nice thing about doing factoring is that I can always check for the solution. If I distribute back in 3 times x squared, I get 3x squared. 3 times a positive 4x gives me 12x. And 3 times a negative 4 gives me a negative 12. Also, something to remember is this. I have 3 terms. And if I have 3 terms in my original expression, I need to have 3 terms inside my set of parentheses. So the number of terms I start with has to be the number of terms that are inside my set of parentheses. Let's take a look at another example. Here I have 8m squared minus 4. Only 2 terms. I have a quadratic term and the constant term. Again, I want to determine the GCF, the largest number that will divide into both of these terms. That number is 4. Now, I just set my parentheses up. 8 divided by 4 is 2m squared. A negative divided by a positive is a negative. 4 divided by 4 is 1. Notice I have 2 original terms, and inside my parentheses I have 2 terms. I can check my solution. 4 times 2 is 8m squared. 4 times a negative 1 is a negative 4. And if we recall, we want to write this as a product of its factors. And the product of its factors is 3 times this quantity. Here, 4 times this quantity. On this slide, we're asked to factor each expression. My first example, negative 15t squared minus 3t. Let's determine the GCF of the coefficients, 15 and 3. The GCF is 3. I have a variable in each term. When I have a variable in each term, and they are common variables, I can find the GCF of those variables. On the previous slide, I had variables in 2 of the 3 terms on my first example, so therefore I could not find a GCF of those terms with a variable because not every term had a common variable. The same with my second example. I had an m in the first term, but not in the second. Therefore, I couldn't factor an m out of each term. It was not a GCF. On this one, I have a t squared and a t. When factoring out a common variable, I factor out the lowest exponent of all the terms. This is a t squared. This is t to the first. Therefore, I can factor out t to the first. A good practice to get into is to have the leading term must be the largest exponent on that common variable. Therefore, whether this term was written first or second, this would be my leading term and should be rewritten as such. Therefore, since this is my leading term, I want this to be positive. It is a negative value. I need it to be positive. Therefore, since it's negative, I want to factor a negative GCF out. Now I set my parentheses. So I always write my GCF and then set my parentheses. I have two terms to start with. Therefore, inside my parentheses, I should end up with two terms. A negative divided by a negative is a positive 5. T squared divided by t leaves me just t to the first power. A negative divided by a negative is a positive. 3 divided by 3 is 1. T divided by t gives me 1. So here is my product of factors. I can check my solution by the distributive property. Negative times a positive is 15t squared. Negative times a positive is a negative 3t. Also remember, I wanted my leading term to be positive. And inside my parentheses, my leading term is positive. And that's a good practice to get into when factoring. My next example, I have 3 terms. They are in descending order of leading terms. Therefore, my largest exponent is first. Then my next exponent is 1, then none. What I want to do is to factor my GCF of my coefficients, 24, 36, and 30. The GCF is 6. I don't have a like variable in each term, therefore I can't factor out a variable. But I did say that I wanted to get into practice of creating a positive leading term. My leading term here is negative. I want it to be positive, and therefore to get that, I need to factor out a negative. So my GCF is a negative 6. Now I set my parentheses. I start with 3 terms. I want to end up with 3 terms inside my set of parentheses. Negative divided by a negative is a positive 4k squared. Positive divided by a negative is a negative 6k. Negative divided by a negative is a positive 5. Product of factors, 3 terms inside my set of parentheses with 3 terms that I started with. I can check for a solution. Negative times a positive is a negative 24k squared. Negative times a negative is a positive 36k. And negative times a positive is a negative 30. Again, we want to factor each expression. Our first example on this slide, p minus p squared. My leading term is the term with the largest exponent on that like variable. I need to put that term first. So this will be rewritten as a negative p squared. Since this is a positive p, I write plus p. Now I want to continue with the GCF. To do that, I want to take a look at the coefficients. They're both 1. They're already in the lowest term. So I can't factor a numeral out. But I notice I have a like variable in each term. Therefore, I can divide out the smallest exponent of the 2 given terms. That would be p to the first. So therefore, p, set my parentheses. But my leading term is negative. Therefore, I want to factor out a GCF that is negative. Now I continue. Negative divided by a negative is a positive. P squared divided by p is p. Positive divided by a negative is negative. P divided by p is 1. Product of its factors, 2 terms on the inside, 2 terms that I start with. Let's distribute to check. Negative times a positive is a negative. P squared. Negative times a negative is a positive p. Second example, again, my leading term should be first, so I'm going to switch the order, which is a negative 24b squared. This is a positive 12b plus 12b. A GCF, 24 and 12 is going to be 12. I have like terms in each. I take out the smallest exponent, which would be b to the first. My leading term is negative, so I'm going to factor a negative GCF. Set the parentheses. 24 divided by 12 is 2. Negative divided by a negative is positive. B squared divided by b is b. Positive divided by a negative is negative. 12 divided by 12 is 1. B divided by b is 1. Distribute. Negative times a positive is negative. 12 times 2 is 24. B times b is b squared. Negative times a negative is positive. 12. B times 1 is 12b. My last example. I have these in the correct order. My variable term, exponent of 2, then 1, then none. I want to factor out a GCF of my coefficients. That will be 2. My like variables are not in each term, therefore I cannot factor out a variable. My leading term is negative, so I'll factor out a negative 2. Now I'll set my parentheses. 3 terms to start with, therefore in the parentheses, 3 terms. Negative divided by a negative is a positive 3a squared. Negative divided by a negative is a positive 4a. Positive divided by a negative is a negative 1. Negative times a positive is a negative 6a squared. Negative times a positive is a negative 8a. Negative times a negative is a positive 2.